Morning, everybody.
Morning, welcome back.
Oh, that's not going to be particularly clear.
Does that match?
Oh, seems to be a theme going
Theme,
on
colour.
here.
It's a colour.
Very nice, very nice.
Today,
Oh,
bearings.
bearings. We've got 1, 2 and 3 here.
There's a reason that we've got 1, 2 and 3. Do you know what that is?
I'm looking for the rules.
The rules.
The
We're
rules
looking
of
for 3
bearings.
rules.
So, the rules of bearings.
Oh.
First rule of bearings.
Had to grab a pen, sorry. First
rule of bearings is we
uh,
must have a
North line?
north line.
Oh,
Okay.
look at that. That's
That
nice.
was quite straight.
Yeah.
I'm quite proud of that. We must have a north line. So, wherever you're dotted, wherever you are placed, whether you are a boat, wherever you are a plane, wherever you are a person, you've got to have
The north line, because you can always find a north line, because you can use a compass to find north, not a pair of compasses, as we discussed. That's like a pair of legs. This is a compass. Use it like that. Ooh, north. Compass.
And then the next thing that we need is that we need to work out where we're going.
Oh yeah.
And
So
when we're working out where we're going,
I'm going to start by heading north, and then I'm just going to turn. Oh, we need a direction, because I might turn that way, you might turn that way, but
we need a consistent way.
Consistent direction.
So our consistent way is going to be
Clockwise, the way a clock goes.
we must go clockwise.
Clockwise.
And when we make that clockwise move, we need to know how much we're going to turn.
So we can measure that using angles.
Using angles. And now you've got to tell us the fact that you told 11x1.
Okay, so we're always going to have to use 3 numbers, and that is so if we're not sure whether or not we heard 30 or 330, because over bad communication you might miss that first number, and you might head off at 30 when someone said 330. So to be sure, we have 0, 30, 030. That's how we say 30 degrees.
Oh, can you do the impression of the
Travelling at 030. Need to hear the first number, 0,
We
30.
must have 3 digits at all times.
3 digits.
That's our 3 bearings.
Hey, 3
Now,
rules. 1, 2, 3.
We're gonna
Draw some?
We're gonna.
Should we go outside?
We're gonna go outside.
We'll see you outside
So
in a minute.
outside in a minute.
It's lovely and sunny. Okay, we're outside. Wow,
Woo!
it's lovely and sunny. It's beautiful out here. I've got myself a compass.
Beautiful stuff.
And we're going to take a bearing. Basically, we've pointed the camera north. So north that's north. And I'm going to go on a bearing of 30.
Yes.
Okay. So I'm going to take my bearing of 30. It's there, and I'm going to go off in this direction because that's obviously 30 degrees.
This where you're going. You're going the wrong way.
Why-
we
why is
just
that the
did
wrong
the
way?
rules.
Well, oh, the rules. We're out here to do the rules.
We did.
Clockwise. Okay, do it again. Do it again. 30. Clockwise. That way, this way. 30. 30. We've got it. We've got 30. That's 30 degrees. We've got 30. Wait. She's gone. She's over there. We're gonna have to go a new bearing. Hang on. Let me just take a new bearing. 50 degrees. We're going to go on a bearing of 50 degrees. Here we go, off on a bearing of 50 degrees. Just undo the camera. Come with me on a bearing of 50 degrees. So that's my north. I'm going to go 50 degrees. Going 50 degrees. We're going to find someone really special who wants to say hello to everyone.
Yeah, someone wants to say hello to you.
They're on a bearing of 120. I'm going to let you find that bearing.
Right, okay. And we're facing north. Got my north line. It's out. I'm going to
I'm on a bearing of 120 degrees. I'm on that bearing. I'm now going to walk.
Okay.
Going to walk, Mr. Payson.
Okay, I'm coming with you.
Walking with my north line. Someone's there. Someone is on the bench.
I said someone was there.
Keep walking.
Go down this
Keep
big
in that
trench,
north
be
line.
careful. Ooh, down the trench.
Oh, we're getting closer.
Yeah,
Who
yeah.
is it?
Are they crying?
Who's going to be there? Who's
Woohoo.
going to say hello?
Are we getting closer?
Who is it? Hello! Well, welcome Year 11. Isn't this wonderful? All of you doing DV. You're never going to have a problem getting lost ever again now. Missing you.
Bye.
Bye.
We better go in.
Better go in.
Oh, okay, we're back in the room. It was nice out there, wasn't it?
It was lovely out there. Oh, we've got ourselves a bearing.
Nice.
Okay, now when we're doing bearings, we
Yeah.
are always talking in some crazy bearing language.
Yeah.
So instead of just going on the bearing from A to B, they always say
Of B from A. From A. I'm guessing that the important words actually are there.
yeah.
Yeah.
So this is saying from A to B.
So that's saying A to B,
yeah.
and that's saying from A
Yeah.
to B.
Yeah.
They mean
So
the same thing.
from
They
A
mean the
or
same
B.
thing. Even though they're the different way around, they mean the same thing.
It's very, very important that you understand that language, okay? So if you're making notes and you're kind of ready for your exam questions, which we're going to send you later, that would be a nice keynote for you to
Shows
pop
how
down.
English comes into maths. Shout out to the English department, doing a good job.
So, we are from A, and we are always at north, okay? And where we are from A and we are going to B, we are making that turn.
Oh, can I draw that in?
Now, when we were outside, we kind of showed you that turning, okay? So now you can picture it. You always need to be the bearing.
Be the bearing.
Okay? So you're at north and you're turning that angle. Always draw on your angle. Draw on your angle of movement so that you know what you're measuring.
Because only a moron doesn't draw one. I just made that up. That's quite good, isn't it?
Brilliant.
You like
So
that?
you need to protract now.
Oh, I'll protract it. Right. Okay, we're going to measure it.
Yeah.
Okay.
So when we're measuring, we need to get a dot on our dot.
Yes, that's the dot on the dot, isn't it?
Yeah, I like the dot on the dot.
I can't. Oh, there it is.
There it is, beautiful. And all look about that is just so nice
That
because
is
the
nice, isn't
line
it? Yeah,
is
it follows the
projecting
line.
onto the.
And so is this one.
So I'm going to say that this angle is 50 degrees.
Yeah, about 50 degrees temper. See, if I was drawing 50, it would be more like that.
Oh.
That's 50 to me.
So what have I done wrong? What have I done wrong?
You've read your protractor wrong.
Oh,
Common
that's
error,
it.
common error.
Common error. So we
Yeah.
need to make sure that we're following from zero. Because when we measure with a ruler,
We start at 0, we never start at
zero.
180.
So we're going to follow the numbers all the way around, and then
mm.
I'm going to therefore
That's
say that it's
better.
130 degrees, which looks
Can you
a
see
lot
that?
better. It's more than 90 degrees. It's an obtuse angle, so we know that 130 is a good shout.
Beautiful.
So, moving on from
Yeah,
that.
moving on.
Oh,
Mistakes.
well, we've done that.
We kind of just did that mistake, didn't we?
But the next thing that I want to talk about is
Distance.
the distances. So in bearings, they do talk about angles, but they also want to know how far away you are from a boat or a person
Yeah.
or a plane. Okay? And where you're drawing it on your paper, that's what we call a scale drawing. So
1 centimetre equals 2 kilometres, and we are going to go for 20 kilometres.
okay. So we're saying that this is 20
kilometres.
kilometres, which means we would need to draw
A line.
a line, which is, what do you think, people?
We'll let you have a think about that. We haven't paused yet.
Oh, we haven't really given any.
Well, you just said, what do you
exercises.
think, people?
What do you think, people?
What do you think, people? And we're
And
back.
back. So I would say that is
10 centimetres.
10 centimetres, and
Because
therefore we
each one of those
draw.
centimetres is 2 kilometres.
They could also switch it up, and they could say 1 centimetre represents 2 kilometres.
They could,
Find
they
out how
could.
many kilometres this is.
Oh, by
so if
telling
you
you measure the line.
measured the line, if I get my ruler, which
Okay.
obviously is
As in, yeah.
which is not
40.
40.
40.
So this is 40 centimetres.
I'll take that back.
So therefore, 2 kilometres for every centimetre would mean that this is actually 80 kilometres away. So they can
Beautiful.
switch it back and forth for you. Okay?
Yep.
All good. Nice. Oh.
Oh, knocked you onto scale. This is a
Ooh.
very important word. Don't always think that you can measure the angle to get the bearing or that you can measure the line to get the distance. Sometimes it says not drawn to scale.
Which means you need to use something else in your repertoire of knowledge. Okay? Here I'm looking at this.
Oh.
And I'm seeing
It looks
two
good, it looks
guys there. I'm
Yep.
seeing two parallel lines.
Ah.
Okay, so here we would be using our parallel line rules. Okay.
What's the question?
The question is going to be, there's going to be 2 questions.
Uh-huh.
It's going to be find the bearing
Find the bearing
of
Mhm.
of Q from P, and then it's also going to ask you to find the bearing of P from Q. Okay, which is a very typical question.
Think about where you're starting from.
So I'm
First
starting
question, we're starting from
P.
P. We're
I'm
here.
at my north line. I'm going clockwise
Can I draw that
round.
in?
You can draw that
Thank you.
angle in.
So I'm starting there, I'm going clockwise, I'm going.
And that is my angle. So here I'm going to use a different angle rule. The angles around a point equal 360, which means this is going to be 250 degrees. So I've got my answer there. Now I'm going to have to find
From Q.
of P from Q, which is at north, turning to
Just this little.
P,
one
just this little baggy one there.
Yeah.
Now, this is using my angle parallel line rules, okay? Here we have, you might know it as co-interior or allied angles.
Allied, yeah.
2 angles inside the 2 parallel lines. And they equal 180 degrees, which means that bearing is going to be 0, 70. Beautiful.
Yep.
Okay, and there I didn't have to use a protractor at all, and that was the clue that you did not need to use
Not
a
scale.
protractor.
You actually just worked it out using a bit of maths.
Bit of maths.
Well done.
Ooh.
Oh.
Here we have our boats. We've got some boats here, Mr. Casey.
Alright.
And we've got boats, and they're just in the middle of the sea.
Yep.
And they're trying to find another boat
Ooh.
that actually might need their help.
Shall I help you with that north line?
Yes, please.
Okay.
Please do.
There we go. Should we draw another one on the other
Yeah,
side?
or we must always have a north line, because that is.
Shall I help myself with that one?
Go for it.
Okay. Is that better?
That's looking straight. That's
2 north
looking good.
lines, little arrows.
Okay, we must always have a north line, that is our number 1 rule. Okay, and we are trying to find the boat C, which is somewhere between these 2 angles. Okay, it is on a bearing of 290 from B, and it is on a bearing of 80 degrees from A. So if we find those 2 bearings,
Yep.
we should find C in the middle.
Okay.
Thanks. So I'm
Scale
going to do.
drawing now.
I'm going to do this bearing.
Okay then.
Now we don't know how far away the boat is,
Yep.
but what we do know is that it is on that angle of 80 degrees.
Okay. So where these 2 lines cross over is where boat C is going to be.
It is indeed. So lining that
Would you
up.
you could look, do this.
Oh yeah.
We can cheat. You don't need a ruler. We can cheat. We are go. Stop. Yeah.
Oh, I think I did that quite well.
Yeah, do you want me to correct it slightly?
Yeah. Well, yeah.
Okay, so I'm going to put that on that end.
And then we line it up so that it's on that pink dot.
There we
Beautiful.
go. Okay.
Mr. Cason's now going to have a go at doing the 290. I've given
Ooh,
him the
290.
nice easy one.
Now, obviously, I know that that bit is 180.
Yeah.
Yeah. So I'm just going to work out what else I would need to make 280.
You could do it that way.
Can I do it that way?
You could do it
So I'm
easier
going to
way.
110. You would think there's an easier way?
I think there
You're
is.
going to take it away and do that.
Yeah, I'm going to do that.
See, I always teach it so I'm always going clockwise.
Oh, so I do quite like that, but I would.
Okay, well talk me through it then. I'll do your
You
way.
know, so 290 take away from 360 is 70 degrees.
So I've got to come 70 from
You come 70 degrees from that way.
Let me make sure we get our
Give
pen
us a
right,
nice
because we don't
dot.
want to make a mistake now.
And remember, you're measuring from 0 from this one, so
Yeah.
you've got 70 degrees there.
Yep.
Now that is your 290 going all the way around like
Okay.
that. And now you can draw your line.
Can I draw a straight line now?
Yeah, go
Which
for it.
dot was it?
Oh,
Well, we got 2
it's
dots.
that one.
Yeah, I thought it was that one. I'm going to do that first.
And then you're going to stretch it.
Yeah.
Oh, you're
yeah.
so smart. And where they
Look at
two
that. Beautiful.
of them cross on a bearing, that is where our lovely little C is. See? Just there.
Just there.
Boom.
Mark on your diagram.
Beautiful. And I think that one is actually one of the most satisfying bearing questions you can have.
Is it?
This next one we're going to do
Oh.
is
Oh.
just for your sort of grade 8, grade 9, so Jacob.
Just for you.
Just for you, mate.
But also, I'm thinking other people. Sophie D. We know she's watching, and she sent me some work. Thank you, Soph.
Very, very nice.
I love it.
If you want a bit
We're
of
going
a
to read
challenge.
it. We're going to read it. Then we're going to step out and get a calculator. We need a calculator for this, but let's read it to you. A ship sails on a bearing of 050 degrees for 200 kilometres. It then turns through an angle of 92 and sails a further 120 kilometres. What is the shortest distance back to port, and what is the bearing the ship needs to sail on to get there?
Something you're definitely going to
A
need.
diagram,
A diagram.
a calculator.
Yeah, because this is all visual.
We'll step out. We'll be back. Okay, so you've got your calculator.
Calculator
Pink.
ready.
I've got my pen because the pen was running out of ink. Okay, 50 degrees, 200. No, I'm going to try and remember that and draw a diagram. The next page. So I'm going to have a north line, I think.
Yeah.
Okay, I'm going to sketch it, so I'm not going to worry too much because I'm not going to be measuring anything. North line. Got my ship. 50 degrees. Now I reckon there, 90, 45, 50. It's about. It's kind of that, really.
Yeah.
Yeah. I'm
like
going to write 050, and I'm going to write 200 kilometres there. And then I'm going to draw another north line, little north there, and it says the ship turns to an angle. Be careful. It doesn't say it goes on a bearing of 92. It says the ship turns to an angle of 92 degrees. Now I'm going to say that it's going this way. Okay, this way, clockwise, 90 degrees. That's straight. That's 90, 92. It's approximately there, so I'm going to pull my ship down here.
I think if we draw on that little
Oh,
visual
okay,
bit, because that was helpful for me. You
Yeah,
know,
so
that's
that-
not so good, Brad.
That is 92 degrees. Yeah.
And the angle there is
That-
still that angle of
That's still
50
50.
degrees, which is really important.
And that is 120 kilometres.
Lovely.
Okay, and we're here. And I'm going to draw another north line. It then says, what is the shortest distance back? Well, clearly,
Straight back.
that's the shortest distance back. And what bearing does it need to travel on to get there? So they're the two things we need.
So we want to find this guy eventually,
Mm-hmm.
and we also want to find that guy eventually.
Okay.
That's your
Now,
aim.
do I know anything else that I can fill in? I think I do. I think I know this angle here.
Correct.
Yeah? Because
Yeah.
that would be 180. That's 92, so that must be 88 degrees.
Nice.
Yeah?
stuff.
Just going to shorten that to that. There you go. 88 degrees. Now I can see something. I've got a length, and an included angle, so I can find out this length using
Cosine.
cosine rule. Okay. A squared equals b squared plus c squared minus 2bc cos a. Okay, now the A is my angle that I'm going to use.
Yeah.
So this is going to be my A, this is going to be my little a, and B and C are these two sides. I usually say B is the small one, C is the bigger one. Okay, so
Yeah. So we're going to get 120 squared plus 200 squared minus
2
times
times 120 times 200.
Oh, that
Oops, sorry,
shadow
my
got
shadow.
me there.
I'm going to make sure that's 200. Because my shadow got in the way, cos 88. Now we're going to do this in two chunks, and I always recommend you do this in two chunks because calculators sometimes get confused with this. So I'm going to work out this side first. Sorry, Miss Cheeseman's going to work out that side first.
Sorry, 54400.
54400 minus, now we're going to work out this side in one chunk. Be careful of the cos 88. 2 times 120 times 200 times cos 88.
1675.1758 ...
And so, I'm going to subtract those. Remember, this is a squared.
52724.82416.
And we are going to need to find a So we are going to square root.
229.619, rounded to 3 decimal places.
Okay, so we now know 229.619. And because we've worked that out, I'm going to write that rounded to 3 decimal places as opposed to rounding it to 230 or anything like that.
Yeah, and always round a couple more decimal places more than what the answer is expected at the end, and then you keep yourself safe.
Yeah.
In terms of
Now I'm going to
errors.
rub all this out in a second, so make sure you drink in the beauty of the cosine rule, because we're not going to need it again.
One bit of advice, this is just an extra thing. That,
Like extra things.
Well, this is actually in AS with my year 12s, and what I ask them to do is once they've got their sketch, hone in on the information that they need, and sometimes draw themselves a new sketch with just the triangle information as they go. Some of you find it a bit overwhelming when you have diagrams with lots of different things on.
Jude finds it overwhelming.
You could draw yourself just a little sketch with now the information that you have if you wanted to.
Yeah.
But it's as you go, it's a process for yourself.
Okay, so I'm going to remove all of this for now, because we don't
Oh,
need
look
it
at that
again.
beautiful mouse
It's
going.
all gone, because we're going to use a different rule for the next bit.
So, we are honing in on trying to find this angle now, okay? And what information do we have?
Well, we know some bits about it already, because if I do that,
Yeah.
we've kind of got information going on here.
Because we've got this angle here and this angle here, we're back to our parallel line rules, okay? And here we have corresponding angles. This angle is the same as this angle, so that is 142.
You've added the 50 and the 92.
Yeah.
So yeah, so that turn there is the same as that turn there. So 50 and 92, 142?
142.
142. So we've got some information about this. What we now need is just this little bit in here. There's a straight line going on. If only I could find out that and take it from 180, it would give me that.
Yeah, absolutely.
And I could find out that because I've got an angle and a side and an angle.
So we're looking at,
pair.
oh wow, in
Sine
yellow.
rule. Should we just make that slightly smaller?
Yeah,
It's a bit blocky, isn't it?
It's a bit yellow.
It is. There we go. Try that.
Okay, well done.
You're going to rub it out? Oh,
Yeah,
I'm going to
I'm
stick with
just
it.
going to go again.
We're going to go with the sine rule because we have got pairs of sides and angles, one of which we don't know, and that is the
And
angle.
we are trying to find the angle, therefore it is the angle on top.
Okay, now you've relabeled them. You've kind of confused me slightly, so I'm going to unconfuse myself. So we're now saying that I'm going to call this A, because it's the angle I'm looking for.
Yep.
I'm going to call this little a. I'm going to call this B now, and I'm going to call this little b.
Perfect stuff.
Okay. Let's
It's
put
always the information that you've got. I feel like there comes some clouding sometimes with labelling, which is not always needed. I think, you know, you just take the information that you've got. Yeah, I'm getting there. I'm getting there.
I know you are. You're chatting.
I'm chatting.
Okay. Should we want sine A on its own, so we're going to multiply both sides by 200. Let's bring the 200 over here.
I'm going to get sine A equals sine of 88 over 229.619
multiplied
by 200. I'm going to whack that in my calculator.
Whack it in your calculator, see what we get. Oh, and that will be sine A.
Careful with your brackets when you're in your calculator.
Yeah, try not to do sine 88 divided by 229 because your calculator will get confused. Find out what sine 88 is first, then divide by 229, then multiply by 200, and you get
0.870477.
But we want A, we don't want sine A.
And we know that's right because we want something that's under 1 because when we sine inverse it, we're going to get an angle.
Yeah, here we go.
So sine minus 1 of that is going to give me 60.5. Oh, that's lovely.
So that is 60.5.
Well, it's 6.514, blah, 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 blah. I think we need a bit more. There we go.
180 take away 60.51 is?
So I'm going to keep my number in my calculator and do 180 minus that, and it's going to give me 119.5.
And the 142 and the 119 gives me a total bearing for my answer of
261. Beautiful.
Okay, so our answer will be to 2 decimal places 229.62, 261 degrees.
Are we allowed to just put that as 261 degrees because it has to be 3 digits because it's a bearing?
No, you can have decimal part. I mean, if you're a pilot and you're not going to fly exactly 261 degrees, it's
Yeah.
over distance, that will make quite an error. So you can have your decimals. What were the rest of the decimals?
4, 8, 6. Or 4, 9 to 2 decimal places.
Four, there we go. Okay.
Looks weird though, doesn't it?
It does look weird, but
Does look weird.
but you know, in the real world, you
Yeah,
need
and you
actual
need that
decimals.
exact, otherwise you might crash
Okay.
into another plane.
You would crash into another plane. Are we done?
We're done.
That was a bit of hard work
That
to
was
change.
epic.
Wasn't it?
That
It was
was
good.
quite
We
epic.
enjoyed that because that was some real maths.
I'm going to try and find some of these in my year 12 resources and add those on to
Nice.
show my homework. Don't feel like you have to do those.
No.
Don't put your hair out, but if you are going for that 8 and 9 and you're not sure whether you want to redo it in November, then this
People
is,
like Alex
this
should
is
should be doing this. Anyone thinking of continuing their maths next year at A level, you really should be continuing with your maths.
or
now.
IB maths.
IB.
This would also be
Helpful.
going on.
Yeah.
Okay, cool.
Good.
Well,
We'll see
you
you
later.
tomorrow. Bye.
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 Ba-dum, dum, dum, ba-ba-doo-dum.